Now, some things that we can use. CD is congruent to itself. That's true. What about the circles? What do they tell you?
That
The circles tell you where M is. Because you draw that line and then M is right there.
you can't use M in the explanation right now.
All right, well, we can't get to that part in the explanation yet.
Okay,
Think about radius of circle.
AB.
Is AB a radius of a circle?
No, my bad.
No.
No, it's not. So we can't use that
Yeah,
yet.
but the radius, I think.
What is a radius of a circle? Or one of these circles?
The radius of this circle is AB.
No, it isn't.
It's not AB, but it's A.
What?
AM.
AM is not a radius of a circle.
AC.
AC is a radius.
And AD.
And AD is a radius.
And BD and BC.
BD and BC are radii.
3 points radius is supposed to be.
So, what can I say AC is congruent to what?
AC is congruent to BC.
AC is congruent to BC. Whoops. Why?
Because they are by definition of radius.
By definition of radius. They are both radii of congruent circles. And I spelled radii wrong.
You're the teacher.
Well, okay, I typed radii wrong. A and W are very close to each other. And radius, look at that. Okay, I fixed it.
No, not this. Go back to it and then go press A.
It's not working.
There it is.
My backspace isn't working.
Okay, your backspace is gonna mess up. There it is.
Okay. All right, now what else can I say? CA? I got CA. AC.
DA is congruent to. Oh no, I would say D.
Is congruent to what?
DB. BD.
BD. Why?
By definition of radius. Same quotations.
All right. Now, think about this triangle that we just kind of sketched out. We have CD as one side, so that's the long, tall middle. All right, and it's part of both triangles. This part right here. Okay, and then we have AC, so from here to here, congruent to BC, from here to here. Then we have AD, congruent to BD. All right, so we have those two long, skinny triangles that kind of make a kite-looking shape in the middle of the eyeball or whatever. All right, now what can you tell me about those two triangles?
I can't say
They're right
Nope,
targets. You probably.
that they are congruent.
they are congruent. Hey,
Well, I
don't
say
write on
CD
each other's
Property.
sticky notes.
No,
Okay.
somebody wrote.
Reflects
Well,
property.
Okay, so triangle what?
When I say CA. Triangle CA
A D
is congruent to CBD.
Is congruent to
Triangle.
C what?
CBD.
CBD. Why?
By. Hold on.
Not definition of radius.
Not definition of radius.
We've used this a bunch of times now.
Oh, that's C.
Not
CPCFC.
CPCFC.
Dang it.
Axiom 2.
Yeah, that.
Side, side, side. All right?
Is it congruent to?
They are congruent.
Okay.
Yeah.
Shut up.
We're going to mark triangle and triangle. Okay. Now we do need to use CPCFC, but we're still not there yet. Okay, this one's gonna get a little crazy now. We're about to use axiom 3, which we haven't used before.
We're about to get crazy.
Well, this joker will fly.
He's gonna get crazy. All right.
Hold on, don't rest it up.
I'm not erasing anything. Now, remember that we want to prove that this side, AM, is congruent to this side, BM, right? So we looked at this overall triangle situation, and now we know that angle ACM is congruent to angle BCM by CPCFC, because we showed that the whole triangles were congruent. All right, now these corresponding parts are congruent to each other by CPCFC. Okay?
I didn't get that. Did you want us to write that down?
We're gonna write it down. I'm gonna talk through it first. All right. So since this angle ACM, this angle, maybe I should draw it.
Are we recording?
Yes.
I can tell.
All right. Angle ACM is congruent to angle BCM. This angle is congruent to that one. All right.
So we're doing the
Angle
triangle.
ACM is congruent to angle BCM.
Right.
What does you say we can't use
Can we
M?
draw that? Just make it look good.
Okay, hang on. We used this bigger triangle first, right? We used this triangle and this triangle. And we just proved that they are congruent to each other. Okay?
It's like a kite.
We proved that this side is congruent to this side. We proved that this side is congruent to this side.
Be drawing that.
You might want to.
Yeah.
And then we proved that the middle is congruent to itself.
Okay.
Okay? So now that we have two triangles that are congruent, tell me which angles are congruent.
Angles. ACB.
ACM, this
and
one,
BCM.
is congruent to
BCM.
BCM, right?
Yes, ma'am.
What else is congruent? ADM is congruent to BDM. And we know one more set of congruent angles.
I was gonna say A, B, B.
Angle A, this one, is congruent to what? CAD is congruent to CBD. Okay. Now we don't need all of that information, but all of that is true. All right. The only part that we need is this angle up here. Okay. Now we're going to use axiom 3. Does anybody remember what axiom 3 says?
I do.
Side, angle, side. So we have a pair of sides that are congruent, right? We have another pair of sides that are congruent,
Yes,
and then we know that the angle in between those two are congruent. Okay? So that means that these triangles are congruent. All right, let's write that out so we can see it all. Okay. So we said that the two big triangles were congruent.
Send out information.
Yes. All right, we said the two big triangles are congruent. Now we're going to say that the angles are congruent by CPCFC.
So we can use axiom 1 and 2 in the same
Yes.
column? Okay.
So we have that angle ACM is congruent to angle BCM by CPCFC. is angle, and this is angle. All right. Then we know that CM is congruent to CM, why?
By reflective property.
By reflexive property. Okay, so, and then we already said that AC is congruent to BC. So that's the first side. And then we have this angle. And then here's our second side, CM and CM. So then we can say that triangle ACM is congruent to what?
It's going to go into BCM,
BCM by
axiom 3.
axiom 3. And that's side, angle, side.
Sass.
So much.
Okay, so then we have triangle ACM congruent to triangle BCM by axiom 3, side, side, side. Now, what was the very last thing that we wanted to say?
I had it. Therefore, going to AM is congruent to MB.
AM is congruent to MB. Can we say that? Can we say AM is congruent to MB?
Yes.
Why?
Because we found out by
Definition of radius.
Not definition of radius because they don't have circles. By
By
CPCFC. All right. Do you see that we have two triangles here? ACM. ACM. That's a triangle that we just said was congruent to BCM. BCM. All right. So that's another triangle. So what are the corresponding parts? AM corresponds to what? Not CM. BM. So they're corresponding parts of congruent figures. So that means that
AM is congruent to
AM is congruent to
MB.
BM or MB, whichever, by CPCFC. Therefore, M is the midpoint of AB. Do what? It's a lot. I might give you a few hints. If I give you a problem that's this involved, I might give you a few hints. It takes practice to know. Just one of the things that I think about is what do I want to end with, and then I kind of work my way backwards in how I want to get there. All right? I want to end with midpoint. What does midpoint mean? It means that they split it into congruent segments. How can I show these segments are congruent? Because I need those two triangles to be congruent, and then I can use CPCFC. How can I show those triangles are congruent? This is what I need to show that. So it is a lot of stuff. I understand that. I'll probably give you a few hints. Like I'll probably say, explain why triangle ACD is congruent to triangle BCD. And then if you can do that, then I might say, explain why triangle ACM is congruent to triangle BCM. So the smaller ones, why are they congruent? And then I would say, finish your explanation showing that M is the midpoint. All right? Now tomorrow on your quiz, it'll be the first time that you're going to actually use your notebooks during your quiz. Since we've got so many definitions and axioms going now, you're gonna be able to use that because you need that for your explanation. Okay, your explanation uses all those axioms and definitions and stuff like that. All right, so what I want you to do now is get your notebooks and add in